Ladies. So we're starting on plant production. I've given you a document that has a lot of this stuff on it, a PDF, and I've put a bit of a checklist up on your Google Classroom as well. So this unit, it's pretty big. There's 21 dot points that we need to cover, but as you'll see, some of these dot points cover a lot of material. So P1, P2, that's going to be all week and probably into next week as well. It's just a lot of stuff in some of these dot points. So we better get started. For P1, we're looking at the structure and function of different parts of the plant. So I've created this document for you. So I've put it on the Google Classroom also. So I've left it as Word so that you can change it to suit your needs, or you can print it off and write on it, whatever works for you. As you can see, so we've got leaves, stem, roots, flowers, seeds, and fruits. What I want you to do is describe the structure. You might put a diagram here, and then the function. So what are the functions for the leaves? So with your structure, a really good idea is to also put in the difference between a monocot and a dicot. As we have a look at our dot points, our second one here is distinguish the external and internal anatomy of monocots and dicots. So it is this one here. We kind of need to do that as we go along, and the document that I've given you that got posted home has all this stuff in it. So let's get cracking. So you can use this sheet for summaries, okay? Now, plant anatomy. So I'm just going to zoom in here. So this is the document that got posted home for you. If you've lost it, you can go to the Google Classroom and I'll put the PDF up there for you. You can use either. Right, so we're going to, so this is also in your textbook, Dynamic Ag, page 257 to 268. Now, roots, so we know what roots are, right? They below the ground, they're for water and for nutrients. So we've got these 5 different functions here. Anchor plants to the ground, absorb water from the soil, absorb minerals, nutrients, conduct absorbed water and minerals to the shoots, to the leaves, and store materials such as starch. Now, starch is a product that comes as a result of photosynthesis. So we've obviously got to transport from the leaves down as well. So it's not just one way. We have materials going both ways. Okay. Now, if we have a look at this diagram here, well, we've got 2 diagrams we're going to look at. We've got these words here that you will be unfamiliar with: monocot and dicot. Now, dicotyledon is like a tree or a rose bush. They are all dicots. Now, the term dicotyledon just means that cotyledon just means seed leaf. Now, di means 2. So when these plants come out of the ground after they've germinated and they've emerged, they have 2 seed leaves. Okay, that's all that means. A monocot has 1 seed leaf. Okay, so it comes out with only 1 leaf. Now, monocots are grasses. Okay, that's the easiest way to think of it. So monocots are grasses. Dicots are everything else. Now, some of the big differences are the root systems. So dicots have this taproot. So looking at this diagram here, we have this taproot, and we have smaller roots coming off it. The monocots have the fibrous root system. So dicots have a taproot. Monocots have a fibrous root system. So they're very different. Now, getting back to general stuff on the roots, we're going to have a look here. Now, this circle here is just a zoomed in area of this root tip here. Now, we have some words here that you wouldn't be familiar with. Meristematic tissue. That is just the tissue that is actively growing. So there is cells being produced in there, okay? In the area behind the meristems, we have elongation, where those cells get longer, okay? So we have meristem, and then we have elongation. And we have a root cap. So the root cap is like a helmet, a protective layer for the shoots as they're being pushed through the soil because of the elongation that's happening here. Okay, so the cells in this area are getting longer and it pushes the root down and through. So the root cap's really, really important to protect the root. Now the next thing is we have the root hairs. Now the root hairs are tiny, tiny parts of the root that come off. And their whole role is to increase the surface area of the root. Now, it's really important to have a huge surface area so that water and nutrients can be absorbed. Does that make sense? So we want as much surface area as we can. Now, for the most part, we don't see root hairs because they're so tiny and they're so fragile. When we're removing roots from soil to look at them, we just don't see them. Okay, they get destroyed. So they're really, really tiny, but they are there. Okay, I think that's that bit. So tap roots and fibrous roots, let's zoom in here. And many plants have roots that are somewhere in between. So if you go out into your backyard and you pull some roots, you usually can tell straight away because of the roots. Some are a little bit more difficult, but you will find with tap roots, there'll be one main root, okay? Remembering that monocots have a fibrous root, so grasses have a fibrous root system, dicots have a tap root. Now, structure and function. So we've got the root hairs. So we've spoken about this stuff. And these root hairs take up water and minerals. I'm going to highlight that. Root hairs increase the surface area of the root more than 10 times, and they take up water and minerals. All of the minerals are used for growth and development. Okay, we've got nitrates, phosphates, and sulfates. Okay, so all of our fertilizers that we buy and apply to our plants, they generally have three main nutrients: nitrogen, phosphorus, and potassium. Okay, so NPK. They are the three major nutrients that our plants require. This will be more important in the coming dot points, so don't really need to go into depth for that there. Now, let's have a look at our diagram here. So we've got a cross section. So cross section is a root cut in half. Now, if we have a look at our dicot root, it has a little star in the middle, okay? Whereas our monocot, it has more of a ring sort of shape to it, okay? So if you're looking at a cross section, that's how we can tell the difference between a dicot and a monocot. Okay, stems. So stems, they're to support the parts of the plant that are above ground. Includes the flowers, buds, fruit, all that kind of stuff. Now, we've got a couple of words here that you won't be familiar with. We've got phloem and xylem. Now, phloem and xylem are the transport system. Xylem goes from the roots to the leaves, and it transports water and nutrients. Now, it's a passive system, meaning that we have a flow of water that doesn't require energy. Okay, we're going to talk about this with leaves. Now, phloem, it transports products from photosynthesis, so the sugars and starches and stuff like that that are produced. Now, it can go both directions. Water goes up. Phloem, it can go both ways. Okay, so if we have a look at our diagram here, we can see that our phloem is on the outside and the xylem is on the inside. Okay. We've got the cortex, which is the outer layer, and then we have pith, which is this inner layer here. Okay, and the xylem and phloem, and we call these vascular bundles. So vascular just means transport. So a vascular surgeon is someone that might work on the heart, but also the arteries and the veins. Okay, so the xylem and phloem have a very similar transport role. Already, I think that is that one. Okay, so if we have a look at, this is a cross section of a monocot stem. Now, the vascular bundles are spread randomly throughout the monocot stem. Okay, now we use the term alien face. This looks like a side-on alien face. Okay, when we get into the classroom and do some pracs, we'll actually be looking at this sort of stuff, and it does. It looks like a bit of an alien. So, difference between monocot and a dicot. The dicots have their xylem and phloem in a ring. It's a distinct ring around, as opposed to dotted all through the plant. Okay, so the xylem's on the inside, the phloem's on the outside. Okay,